to make a wild, completely unproven guess.
What a fascinating challenge to leave you with. Thank you for joining us on this deep dive. When we talk about the future of artificial intelligence, there's this dominant narrative. It's almost inescapable.
Yeah, this idea that we're basically hurtling toward a cliff edge.
Exactly. Or, well, let's use a more specific and terrifying image from our source text. Picture this. You walk into a room, right?
Right.
And you see a group of small children playing with an undetonated bomb.
Oh, wow. That is dark.
It is. It's a heavy ticking device. And these kids are just, completely oblivious to the mismatch between the catastrophic power of this thing and their own immaturity.
I mean, if you put your ear to it, you can hear a faint ticking sound.
Right. And the sensible thing to do would be to gently put it down, back out of the room, and find an adult.
Which we are notoriously bad at doing.
We really are. But in this scenario, there isn't just one kid. There are many. And each of them has access to their own independent trigger mechanism.
So the terrifying conclusion is...
some little idiot is bound to press the ignite button just to see what happens.
Yeah. The visceral dread of that image is just incredibly potent. I mean, it bypasses the analytical brain completely.
Goes straight for the amygdala.
Exactly.
It really is pure nightmare fuel. And, that dread is exactly what Oxford philosopher Nick Bostrom was trying to capture. He used that analogy in his 2014 bestseller, Superintelligence.
Right. He paints this picture where we are just kids tinkering with a detonation that will fundamentally alter reality.
The moment one of these machines gets smart enough to start upgrading itself.
Yeah. And he presents this not as like a vague sci-fi possibility, but as a fait accompli. A done deal.
The cultural message you absorb is basically stop arguing about whether the intelligence explosion is coming and start bracing for the shockwave.
But today, we are diving into a stack of sources, specifically zeroing in on the arguments laid out in Chapter 3 of our main text.
Right, because our mission for this deep dive is to systematically deconstruct this exact anxiety. We are taking a magnifying glass to the concept of the superintelligence error.
We are looking at the foundational wiring of this supposed bomb.
Yeah.
Because the core thesis of Chapter 3 argues that this entire assumption is flawed.
The idea that an AI intelligence explosion is just this inevitable ticking clock.
Exactly. The text argues it's built on a cascade of logical errors, philosophical sleights of hand, and some really profound biological misunderstandings.
So if you actually open up the casing of the bomb Bostrom describes,
you might find that the wires don't actually connect to a detonator at all.
I love that. And I want to spend our time today mapping out exactly where those wires fail to connect. So for you listening, by the end of this conversation, you are going to have a rigorous academic framework.
A framework to really question the loudest voices in the tech world.
Because we aren't going to just skim the surface. We're going to trace this idea from its origins in the cryptography labs of World War II.
We'll walk through the complex mathematical theory of self-reproducing automata.
And untangle some heavy-hitting thought experiments about the very nature of human cognition.
To understand why the modern narrative is so flawed, we really first have to understand where the blueprint for this bomb was initially drafted.
You have to go back to the mid-20th century, specifically Bletchley Park.
Right, the hub of British code breaking during World War II.
When most people think of Bletchley, they think of Alan Turing, right? Yeah. The Enigma machine.
Naturally. But the architect of the specific anxiety we're talking about today was actually Turing's colleague, Jack Good.
Jack Good. He was a brilliant mathematician in his own right.
He really was. He worked closely with Turing, and, they spent a lot of time theorizing about the future of the computational machines they were building.
Turing had already been laying the groundwork for the idea that computers could eventually reach human-level intelligence.
And Good took that foundational premise and extrapolated it to its most extreme logical conclusion. In a famous 1965 paper, Good proposed a concept he called the intelligence explosion.
The intelligence explosion.
Yeah.
And Good's logic, it seems almost deceptively straightforward at first glance.
Oh, totally. He argued that if we can build a machine that reaches baseline human-level intelligence, that machine would inherently possess the capability to examine its own cognitive architecture.
It could just look at its own code.
Right. It could then design a slightly better, slightly smarter version of itself. Then that new machine does the exact same thing, but faster and better.
It creates a feedback loop.
He envisioned an exponential curve, a runaway sequence where machines quickly leave even the greatest human geniuses in the dust.
Resulting in what he termed ultra-intelligence.
Exactly. He famously declared that an ultra-intelligent machine would be the last invention that man need ever make.
Assuming, of course, that the machine is docile enough to tell us how to keep it under control.
A pretty massive assumption, yeah.
Okay, well, I have to jump in here and defend the intuitive appeal of Jack Good's argument for a second. Because when you look at the history of computing, it feels like Good was just anticipating Moore's law before Gordon Moore even formalized it.
I see where you're going with this.
Like, if we look at processing power, compounds, right? It's a basic math equation. Compound interest for brain power.
Right, 1 + 1.
Exactly. If a machine has an intelligence level of 1 and it uses its computational speed to add a +1 to itself, now it's at 2, then 2 becomes a 4, 4 becomes 8, and suddenly you're at 1 billion.
It scales incredibly fast.
Yeah. So when you combine that mathematical compounding with the billions of dollars pouring into Silicon Valley AI labs right now, I have to ask, why wouldn't that mathematical inevitability hold up in the real world of cognition?
Well, the fatal flaw in the Good-Bostrom argument is that it relies entirely on us accepting the premise without demanding the mechanism.
The mechanism.
Yeah. They present this baseline concept, a machine making itself super intelligent, that's so self-evidently plausible that it doesn't require further mechanical explanation.
They just gloss over the how.
Exactly.
Yeah.
But in computer science, and in biology for that matter, you absolutely need the how. Our source text identifies this first major logical gap as the hardware fallacy.
The hardware fallacy. Let's pull that apart. That assumes that adding more processing power natively generates higher intelligence.
Right. If we look at someone like Ray Kurzweil, his entire prediction of the singularity is based on the inexorable exponential shrinking of transistors.
The growth of computational speed.
Yeah, he points to the hardware graph going up and says, see, superintelligence is next.
But the text gives a really good structural analogy to test that logic.
The library analogy.
Yes.
Yeah.
Imagine you want to write the greatest, most insightful novel in the history of human literature.
Okay, I'm with you.
To achieve this, you decide to build a massive, state-of-the-art library. You pour billions into constructing miles of oak bookshelves.
You install the fastest robotic retrieval systems.
You climate control the entire facility perfectly. You have optimized the physical infrastructure to an unprecedented degree.
That's the ultimate hardware.
Exactly. But does the mere existence of those empty shelves author the novel?
Obviously not. You just have a very fast, very expensive empty room.
Right. You've increased the capacity to store and retrieve information, but you haven't generated the creative insight required to actually synthesize a new narrative.
And the hardware fallacy operates on that exact same blind spot. Increasing RAM, adding more server farms, or speeding up the processor.
Like getting a faster MacBook.
Right. Making a MacBook load applications faster does not spontaneously generate cognitive insight. It doesn't make it smarter in any meaningful cognitive sense.
Because if intelligence means anything interesting, like if it involves common sense or abstraction.
Or original thought. It has to be infinitely more complicated than just loading applications faster or storing more data.
So the proponents of the intelligence explosion leave the mechanism of cognitive generation entirely unsaid.
They gesture vaguely at hardware improvements. They rely on a leap of faith that cognitive breakthroughs will magically follow the silicon upgrades.
Okay, so if hardware scaling isn't the magic bullet, then AI proponents usually retreat to a biological argument.
Oh, this is the other major defense. You see it constantly in tech op-eds.
Yeah, they borrow the language of Darwinism. They declare that computational capability doesn't just improve through engineering, it evolves.
Right. They imply that just as human intelligence evolved from lesser primates through natural selection, machine intelligence will naturally cross the threshold into superintelligence.
But looking at biology actually exposes the second massive glaring omission in their worldview.
It really does. Because if we examine the biological world, which is, the only place where true general intelligence currently exists, we find exactly zero evidence of any intelligent entity ever consciously designing a more intelligent version of itself.
I want you listening to really let that sink in for a second. We humans have been around for a long time. We consider ourselves the apex of known intelligence.
We can build space stations, sequence genomes, split the atom.
Yet in the entire span of human history, we have never constructed a more intelligent version of our own brains.
We can undoubtedly educate ourselves, sure.
We can absorb new information, develop analytical skills.
But that is uncontroversial self-improvement through software acquisition, to use a clumsy metaphor.
Right. Reading a book isn't changing your brain's hardware.
Exactly. It is not the same as fundamentally re-architecting our biological cognitive capacity to create a newly evolved superior brain structure.
And we haven't done that because we are trapped by a phenomenon the text calls cognitive opacity.
Cognitive opacity, meaning the actual mechanics of our own intelligence are completely hidden from us.
We don't have the admin privileges to view our own source code.
That's a great way to put it. Before you can build a structurally smarter brain, you first have to understand exactly how the current one operates at a mechanistic level.
And we simply don't.
We really don't. We don't understand how our own brains are cognitive. We don't know the mechanical steps of how we imagine a hypothetical scenario,
Or how we hold abstract concepts in our minds.
or how we combine them to experience an epiphany. Think about when you're struggling with a complex problem, and the solution suddenly just pops into your head while you're taking a shower.
Oh, all the time.
We have absolutely no idea how that buzz of biological magic actually processes the information.
It remains vastly uncharted territory, despite millennia of philosophy and decades of advanced neuroscience.
Which exposes a massive paradox in the AI explosion narrative.
Yes. Because if we don't understand our own buzz of biological magic, why on earth do we assume a machine will magically possess total insight into its own global cognitive capacities?
The entire endeavor suffers from profound circularity. The theory assumes that a human-level AI will be able to do something that actual human-level intelligence fundamentally cannot do.
It takes an incredibly profound, arguably superhuman level of general intelligence to even comprehend how to increase general intelligence.
AI proponents assume this clean, linear progression. Step 1, human-level AI. Step 2, self-analysis. Step 3, superintelligence.
So when you look closely at step 2, there is no linear progression.
There's just a mystery masquerading as an engineering schematic.
And our sources reveal that this isn't just a modern critique cooked up by 21st century skeptics.
No, not at all.
This exact flaw was identified rigorously and mathematically decades before anyone was holding a smartphone.
By one of the greatest scientific minds of the 20th century, John von Neumann.
He effectively dismantled the intelligence explosion before Jack Good even published his paper.
Von Neumann's contributions to mathematics, quantum mechanics, and early computing are almost unparalleled.
And what makes his critique so devastating is that he was not a Luddite. He wasn't some AI pessimist.
Right, he was one of the founding fathers of computational theory. But while Jack Good was indulging in the sci-fi optimism of ultra-intelligence in the 1960s, von Neumann had already tackled the actual mechanical logic of self-improving machines.
In the late 1940s, and he arrived at a fundamentally different conclusion.
So let's go back to 1948. Von Neumann gives a lecture at the Hickson Symposium in Princeton.
He is addressing the theoretical problem of self-reproducing machines.
But he wasn't looking at this through the lens of hypothetical futurism. He was looking at it through the strict structural logic of automata theory.
He wanted to know, mathematically, what are the minimum requirements for a machine to build another machine?
He stripped all the emotion and the sci-fi out of the equation. He pointed out that biological reproduction sometimes results in improved designs.
Through the messy, agonizingly slow process of evolution and environmental selection.
Right, but machines face a fundamental kinematic stumbling block when tasked with designing new and better machines.
Because biological evolution doesn't have a blueprint or a goal, it's just blind variation and survival.
Exactly. But building a machine, is an act of conscious synthesis. The parent machine has to actually specify the design of the new machine.
So von Neumann formulated a concept we can call the complexity paradox.
He proved that any parent machine tasked with designing and constructing a new machine must contain within itself the complete specifications of the creation,
plus the apparatus to assemble it.
plus the instructions on how to read those specifications.
Therefore, the synthesizing organization, the parent, is necessarily more complicated and of a higher structural order than the organization it synthesizes.
The parent must be more complex than the child.
Which completely flips the compounding math equation we talked about earlier.
It does.
To make this tangible, let's look at car manufacturing. To build a modern car, you don't just need the raw materials. You need an entire, sprawling automotive factory.
Right, a massive facility.
That factory contains robotic welding arms, intricate conveyor belt systems, quality control lasers, and the digital blueprints for the car.
The factory is infinitely more complex and of a much higher organizational order than this single car that rolls off the assembly line.
The creator must encompass the entirety of the creation, plus the mechanism of creation itself.
Von Neumann stated it so plainly. An organization which synthesizes something is necessarily more complicated than the organization it synthesizes.
So the natural tendency of such a mechanical system, without external creative input from an outside intelligence like a human engineer, is devolution.
Devolution, not evolution. The offspring will be simpler than the parent.
Which puts an absolute brick wall in front of Jack Good's exponential curve. Good's ultra-intelligence relies on the machine making something smarter and more complex than itself.
But von Neumann proved mathematically that the arrow of mechanical progress natively points downward.
Okay, but let me push back here on behalf of modern computer science. Because when von Neumann was doing this math in 1948, he didn't have access to modern genetic algorithms.
Or evolutionary computing.
Right. Today, AI labs use machine learning models that introduce random mutations into their code. They test them against a fitness function and evolve better solutions over thousands of generations.
It sounds like biology.
It does. Isn't that a form of mechanical evolution that bypasses von Neumann's paradox? Doesn't adding a randomizing element simulate biological mutation and allow the machine to improve itself?
It's a great question, but von Neumann actually anticipated that exact counter-argument.
Wait, really? In 1948?
Yes. He sketched out the kinematic requirements for a self-reproducing automaton. He theorized it would need a stimulus organ to receive instructions, a fusing organ to connect parts, a cutting organ to sever connections, muscle, and so on.
Okay.
And he explicitly considered the idea of adding a randomizing element to the machine's programming to act akin to a biological mutation, hoping it might spark an improvement.
So why doesn't that work for generating superintelligence?
Because introducing random noise into a highly structured, specifically engineered system is fundamentally different from biological mutation in an organic ecosystem.
How so?
Think of an incredibly complex, beautifully crafted Swiss watch. It tracks the time, the phases of the moon, the leap years.
A highly ordered system.
Exactly. If you introduce a randomizing element into that system, say you take a sledgehammer and give the side of the watch a firm tap, are you going to miraculously create a watch that now also measures barometric pressure?
No, you're just going to shatter the gears. You're going to break the watch.
Right. The system is too rigidly defined to benefit from random trauma.
A random change in an exceedingly complex system is far more likely to be a lethal mutation.
Von Neumann concluded exactly that. The overwhelming probability of a random change in a complex mechanism is non-function. It is a lethal mutation.
He acknowledged that a random mutation might occasionally be non-lethal, sure.
But waiting around for millions of years for a lucky sequence of non-lethal mechanical mutations to slowly build superintelligence, that is not what the AI proponents are promising.
Right. Bostrom's bomb isn't on a 3 million-year timer. The Silicon Valley narrative is that this explosion is going to happen in a laboratory on a Tuesday afternoon in the next decade.
Exactly. For an artificial system to actually yield a fundamentally smarter design in a compressed time frame, it would require the parent system to possess a Promethean spark.
A genuine, creative, insightful leap that defies the structural limitations of its own programming.
And von Neumann warned his colleagues that no existing science or engineering theory could account for generating that Promethean spark mechanically.
So in 1948, von Neumann laid out the mathematical proof that detonated the concept of the intelligence explosion.
He really did.
So we have this massive theoretical roadblock. Von Neumann tells us the parent must be more complex than the child, and that random mechanical mutations are mostly lethal.
But Chapter 3 doesn't just leave us in the theoretical physics of the 1940s.
No, the authors construct an incredibly robust modern thought experiment.
To illustrate how this theoretical roadblock manifests in contemporary AI research.
Let's set the stage for this grand thought experiment, because it grounds the theory by forcing us to look at the baseline assumption we touched on earlier.
The assumption that we are human. We possess human-level intelligence.
Right. So if Jack Good's theory holds, that human-level intelligence is the threshold required to design something better, then we humans should be currently capable of designing something smarter than ourselves right now.
But the reality is we are completely paralyzed by cognitive opacity.
The AI proponents are essentially taking the profound, unsolved mystery of human cognition, downloading it into a hypothetical computer and saying, don't worry, the computer will solve the mystery for it.
It's a magical delegation of the impossible.
To expose the absurdity of the circularity, the text introduces us to a hypothetical scenario involving an AI researcher. Let's call her Alice.
Okay, Alan.
Alice works for a cutting-edge startup. Let's call it ultra plus me. And she is tasked with triggering the intelligence explosion. Alice's goal is to build an AI that is exactly as smart as her next-door neighbor, Bob.
Now, Bob is the perfect baseline for this experiment because Bob is remarkably unremarkable.
Alice considers him quite dull.
He isn't a mathematician, he isn't a philosopher, but Bob possesses something incredibly profound: common sense.
He can sit on his porch, read the morning newspaper, infer the geopolitical subtext of an article, and hold a totally normal conversation with Alice about the weather.
Bob's ability to seamlessly navigate the ambiguity of the real world makes him functionally worlds ahead of the absolute best AI systems currently coming out of Google or OpenAI.
To map out why Bob is so functionally superior despite being intellectually average, Alice categorizes intelligence using a dual framework.
A framework inspired by the Nobel Prize-winning psychologist Daniel Kahneman.
Let's spend some time on Kahneman here because his work is foundational to understanding where AI research goes wrong.
Kahneman wrote Thinking Fast and Slow. He famously divided human cognition into System 1 and System 2.
System 1 operates automatically and quickly with little or no effort.
It's the heuristic brain. It's what you use to read an angry facial expression or drive a car on an empty road.
And System 2 allocates attention to the effortful mental activities that demand it, including complex computations. It is slow, deliberate, and logical.
The problem is that the AI field often misinterprets or flattens Kahneman's biological reality into computational metrics.
So in our thought experiment, Alice adapts this into a rough blueprint for artificial intelligence. She divides the challenge into what we will call System X and System Y.
Let's define those. Alice's System X represents competence on strictly defined, rules-based tasks.
This is the domain of narrow AI. Think of AlphaGo mastering the game of Go, or a calculator performing flawless arithmetic.
It relies on brute force computation, vast memory, and clearly defined parameters of success and failure.
System X is essentially the modern tech industry's comfort zone.
Right.
So what is System Y?
System Y represents the Holy Grail, general intelligence. This encompasses the messy, ambiguous reality of human cognition.
It includes Bob's competence at reading the newspaper.
But it also covers the profound abilities of generating novel ideas, experiencing sudden insights, understanding context, and using common sense.
Summarizing a children's story, navigating an unpredictable world where the rules are constantly shifting.
Exactly. So mapping this back to Bob, Bob is functionally terrible at System X tasks.
He is horrible at chess. His short-term memory is flawed.
If you gave him a standardized logic puzzle, he would struggle. His System X is pathetic compared to a 10-year-old pocket calculator.
Yet Bob fully possesses System Y. He has naturally solved the problem of common sense reasoning.
He can pass a Turing test effortlessly. He can read a nuanced children's story, understand the unwritten moral implications, and summarize the emotional arc perfectly.
Because he possesses System Y, he utterly blows away the most advanced natural language processing systems in existence.
So Alice realizes that if she can just build a machine that replicates Bob's baseline System Y intelligence, a Bob machine, it would be the greatest leap forward in AI history.
And following Jack Good's logic, once the Bob machine exists, it can use its computational speed to redesign a smarter version of itself, igniting the explosion.
So Alice begins engineering the Bob machine. But how does she tackle the opaque mystery of System Y?
She doesn't.
She doesn't. She takes the path of least resistance, which mirrors the current methodology of the entire tech industry.
She tries to backdoor her way into System Y by aggressively maximizing the Bob machine's System X capabilities.
She gives the machine a massive hardware and data upgrade. She connects it to the entirety of Google's search index. She gives it perfect recall and petabytes of processing power.
And this is where we encounter the optimization error. The text brings in the crucial perspective of AI researcher Stuart Russell here.
Stuart Russell points out that optimizing System X without a foundational understanding of System Y does not organically generate superintelligence.
It simply allows the computer to arrive at the wrong conclusions much more quickly and confidently.
Because the machine has infinite data but zero common sense to filter it.
The Bob machine memorizes every single blog post, academic paper, and forum rant on the internet, but it lacks the situational awareness to distinguish reality from fiction.
It fails to ask contextual questions.
Alice ends up with a machine that confidently regurgitates absolute crackpot theories because it has all the facts. But from a System Y perspective, it fundamentally misunderstands how the world actually works.
The Bob machine can now play flawless, unbeatable chess. It can calculate the digits of pi to a trillion places.
But its systemic lack of common sense makes it entirely useless for Alice's ultimate goal.
She is forced to admit that this machine, despite its massive data and speed, has absolutely no capability of looking inward to redesign a more intelligent version of itself.
This triggers Alice's massive epiphany about the circularity of her entire project.
Walk us through that epiphany.
She realizes that Bob, the biological human, could not sit down with a pen and paper and draft the blueprints for a cognitively superior version of himself. Bob doesn't know how his own insight works.
So why would the Bob machine, a Millikan replication of Bob's baseline intelligence, suddenly possess the divine capability to re-engineer its own cognitive architecture?
Think about it. If I asked you listening right now to just sit down and design a biologically smarter version of yourself, you couldn't. You don't have the blueprints to your own insights, so why would a machine copy of you be able to do it?
The capability for self-reflection, for cognitive assessment, for experiencing the aha moment required to innovate a new architectural paradigm, these are entirely System-Y functions.
And that is precisely where the Bob machine is deficient.
It lacks the very tools required to bridge the gap. Optimizing System X did not supply the necessary resources to System Y. It just created a very fast idiot savant.
Which threatens to derail Alice's entire career at Ultra Plus Way. Because if human-level intelligence isn't enough to bootstrap a superintelligence, the entire Jack Good narrative collapses.
But Alice is stubborn. She panics at the implications and she pivots. She refuses to abandon the theory.
She decides the flaw isn't in the logic, the flaw is Bob. Bob is simply too dumb. If Bob is too dull, she needs a smarter baseline.
She decides to aim for a machine as intelligent as Alan Turing himself. But attempting to reverse engineer Turing directly is too daunting given her failure with Bob.
So she adopts a staircase approach. She decides to build a machine modeled after Hugh Alexander. Let's call it the Hugh machine.
For those who don't know the lore, Hugh Alexander was Turing's brilliant colleague at Bletchley Park.
Crucially, he was a former British chess champion and an exceptionally brilliant cryptanalyst.
He had undeniable, highly measurable intelligence.
Alice's hope is that if she can build a Hugh machine, it will be smart enough to figure out how to wire the ultimate Turing machine.
Which will then trigger the explosion. So Alice sets to work on the Hugh machine, utilizing the exact same methodology she used on Bob.
She maximizes its System X.
Since Hugh was a chess champion, she easily gives the machine superhuman chess abilities by integrating state-of-the-art chess engines, like Stockfish code.
She gives it perfect calculation and vast memory. System X is fully optimized.
The Hugh machine can now perform calculations that the biological Hugh Alexander could never dream of.
But then Alice hits a catastrophic logical wall, the equivalence problem.
This is the crushing realization. Alice looks at her two creations. She realizes that the heavily optimized Hugh machine and the heavily optimized Bob machine can perform all the exact same tasks.
Provably, mathematically, they are equivalent.
Because she just gave them both the ultimate System X upgrades.
They both have perfect memory and perfect calculation now, but neither of them gained a single ounce of System Y insight from those upgrades.
Elevating System X does not bridge the gap to System Y. Starting with a smarter human baseline did absolutely nothing to solve the fundamental opacity of general intelligence.
The upgrades were an illusion of progress. Alice realizes that abandoning the Bob machine for the Hugh machine was an exercise in self-deception.
And taking this logic to its absolute ultimate conclusion, she confronts the reality of Turing's black box.
Let's explain Turing's black box, because this is where the entire concept of the intelligence explosion finally short-circuits.
Alice realizes that the further we move away from System X tasks like calculating math or evaluating chess positions, and move towards System Y tasks like insight, innovation, and original thought, the more opaque the cognitive design becomes.
Even to the thinker themselves.
Exactly. Alan Turing could easily assess his own System X capabilities. He knew he wasn't as good at chess as Hugh Alexander. He could measure that.
But Turing could not assess his own System Y capabilities.
Turing's intellect, his ability to generate profound, paradigm-shifting ideas, was a black box to himself.
He couldn't write an algorithm explaining how he came up with the concept of the universal Turing machine.
Our source text makes a really profound observation here. General intelligence doesn't just exist as a static, readable blueprint in the brain. It sits in time.
It sits in time.
Yes, across a lifetime. General intelligence is a dynamic, situated process that plays out across a lifetime of interactions with the physical and social world, producing unpredictable and inexplicable ideas.
It's not a spreadsheet you can audit. It's a continuous, unpredictable reaction to reality.
Exactly. It is entirely possible that Turing, in any given moment, might still produce new, completely unpredictable ideas 10 years down the line.
You cannot quantify, map, or mechanically optimize an intelligence that is continually interacting with the world and generating inexplicable insights over time.
Turing's system-wide intelligence was a mystery to outside observers, and it was a mystery to Turing himself.
So the cascading error becomes undeniable. If the greatest minds in human history, Turing, von Neumann, or our hypothetical AI researcher Alice, cannot peer into the black box of their own system-wide insight to map it and upgrade it.
How in the world is a mechanical copy of that intelligence supposed to do it?
The intelligence explosion requires a mechanical entity to do something that the very intelligence it is mimicking fundamentally cannot do.
The idea has a false premise built right into its foundation. If the entire theory relies on the notion that once a system reaches human-level intelligence, it can design a smarter version of itself, the fatal flaw is glaring.
We already have human-level intelligence. We cannot do it.
Therefore, the linear compound interest assumption of an intelligence explosion is an illusion.
So, if the conscious, deliberate engineering of superintelligence, Alice's method, is logically flawed and trapped in von Neumann's paradox, how do the true believers in the tech industry justify their absolute certainty?
Because they don't seem deterred by these arguments.
Not at all. They just say, it's inevitable. How do they bypass this brick wall?
When the mechanical logic fails, they change the vocabulary. They abandon the concept of conscious design entirely and adopt a teleological, quasi-biological worldview.
Enter the evolutionary technologists.
Or ETs, as the authors of Chapter 3 refer to them.
We are talking about figures like Kevin Kelly, the co-founder of Wired magazine, who wrote What Technology Wants, and of course, Ray Kurzweil.
The ET perspective argues that superintelligent AI isn't going to be built line by line by a programmer in a lab.
Instead, they claim it will emerge as a natural, cosmic, evolutionary process on the planet.
Much like organic life evolved from single-celled organisms.
Kevin Kelly uses the term intelligenizing. He argues that the entire universe has a natural trajectory toward greater intelligence, and that technology is just the next phase of that evolution.
The idea is that complex, superintelligent forms of technology are going to spontaneously emerge from the internet without any explicit top-down human design.
The evolutionary technologists look at the World Wide Web and they don't see a network of servers routing data. They see a giant, gestating, emergent planetary brain.
In this sci-fi vision, humans aren't the final creators. We are merely the biological scaffolding required to birth the next phase of evolution.
Once the planetary brain wakes up, we are just a transitional link in the cosmic chain.
They've literally taken Darwinian evolution and copy-pasted it onto silicon.
But biological evolution takes millions of years. To maintain the anxiety of the ticking bomb, the ETs have to explain why AI is going to happen in our lifetimes.
This is where Kurzweil's law of accelerating returns provides the necessary urgency.
Right. Kurzweil argues that technological progress, unlike biological evolution, accelerates exponentially because each new technology is used to build the next one.
Therefore, the ETs conclude that this emergent planetary superintelligence will arrive in drastically compressed timeframes.
They present this not as a difficult engineering challenge, but as a tidy, inevitable law of physics.
I want to really dig into the expert critique of this worldview, because when you read Kurzweil or Kelly, their optimism is infectious. It sounds so grand and cosmic.
But how does Chapter 3 deconstruct this evolutionary technologist narrative?
The text is unapologetically harsh on this perspective. It harshly critiques the ET worldview as a massive, convenient philosophical cop-out.
A cop-out.
By framing superintelligence as an inevitable evolutionary force of nature, it conveniently absolves individual AI researchers from the immense, perhaps impossible responsibility of actually having to make specific scientific breakthroughs regarding cognitive architecture.
That is a devastating critique. If Alice at Ultra++ hits a wall in her research, she doesn't have to admit that general intelligence is mechanically opaque.
She can just wave her hands and say, well, the planetary brain is still gestating. Evolution will take care of the details.
It acts as the ultimate free pass for a lack of progress in actual system-wide intelligence. They don't have to understand the brain, they just have to build more data centers and wait for evolution to do the heavy lifting.
Exactly.
But I'm going to play devil's advocate here, and I'm going to push back hard. Because whenever skeptics claim that a technological leap is impossible, AI researchers have a famous historical counterexample: Locked and Loaded.
The atomic bomb analogy.
Yes. They always bring up Ernest Rutherford and Leo Szilard. And it's a compelling story.
It is a staple of AI defense literature.
In 1933, the great physicist Ernest Rutherford publicly pronounced that anyone looking to extract energy from atoms was talking moonshine. He declared it practically impossible.
Right.
And then, literally 24 hours later, the physicist Leo Szilard was walking down a street in London, stopped at a traffic light, and had the sudden insight into how a nuclear chain reaction could work.
The Promethean spark.
Exactly. The AI proponents use this to say, look, even the greatest scientists can be spectacularly wrong about what is structurally impossible. Therefore, you shouldn't bet against AI science. Superintelligence is our nuclear chain reaction, and our Szilard might be walking through Silicon Valley right now.
It is a potent rhetorical weapon, primarily because it preys on our fear of being on the wrong side of history.
But the source text meticulously unpacks why this analogy completely falls apart upon closer epistemological inspection.
There is a crucial fundamental logical distinction between what Leo Szilard did and what the evolutionary technologists are doing, and it comes down to the accepted rules of the scientific method.
Explain that distinction. Why does the Szilard defense fail?
When Szilard conceptualized the nuclear chain reaction, he was operating within the framework of theoretical physics, a framework that was strictly testable.
He could take his insight, design an experiment, bombard isotopes with neutrons, measure the resulting radiation,
And definitively prove or disprove his hypothesis. The physics of the atom exist in the physical world and conform to falsifiable laws.
whereas the theories of the evolutionary technologists.
The theories about a global emergent consciousness magically evolving out of interconnected internet servers are entirely unfalsifiable.
Let's define falsifiability for a moment, because it goes back to the philosopher Karl Popper. For a theory to be considered scientific, there must be a way to prove it wrong.
Precisely. If I hypothesize that water boils at 100 degrees Celsius, you can test it. If it boils at 90 degrees, my theory is falsified.
But if Kurzweil predicts that true AI will organically emerge from the internet by the year 2029, and 2029 comes and goes with no superintelligence,
Do the ETs admit their theory of emergent evolution is flawed? No. They simply adjust the accelerating curve and push the failed prediction a few decades further into the future.
because the claim relies on a mystical emergent process rather than a mechanical testable mechanism, it can never be proven false.
According to the rigorous standards of the scientific method, an unfalsifiable claim is fundamentally unscientific.
So the inevitability of the AI explosion isn't predictive science at all. It's eschatology. It's technotheology masquerading as engineering.
The authors of Chapter 3 refer to the claims made by Good, Bostrom, and the ETs as imagination pumps.
Imagination pumps.
These narratives ask us to bypass structural logic and just think if this could be. They punk up our anxiety and our excitement, drawing millions of dollars in funding without actually building any foundational scientific pipeline to reality.
Imagining a what-if sci-fi scenario is fundamentally different from a serious, grounded discussion about technological capabilities.
Imagination pumps. That phrase perfectly captures the Silicon Valley hype cycle.
And this brings us back to the core contextual failure of Jack Good's original proposal. To actually engineer a superintelligence, you wouldn't just need a blueprint for the brain's internal mechanics.
The entity would need an immense amount of contextual, lived knowledge about the real world to function with general intelligence.
Good treated intelligence as if it were a narrow, mechanical function isolated in a vacuum. A pure System X calculation.
But as we discussed with System Y, true general intelligence is inherently social. It is situational. It involves interpreting the messy, contradictory nuances of human culture.
Where is the remotely plausible blueprint for engineering an entity that can natively navigate human society better than a human simply because it has faster silicon processors?
It does not exist.
Let's bring this deep dive to a close by synthesizing the incredible journey we've been on. Because Chapter 3 concludes that the superintelligence error isn't just one single mistake.
It's a multiplication of reductive sleights of hand stacked on top of each other.
Let's review the chain of logical fallacies. First, assuming hardware equals intelligence.
The absurdity that adding memory generates cognitive insight.
Second, ignoring von Neumann's complexity paradox.
Mistaking the fact that a parent machine must be more complex than its child.
Third, mistaking System X optimization for System Y insight.
As we saw with Alice and the Bob machine.
And finally, hiding behind unfalsifiable evolutionary pseudoscience.
The evolutionary technologists.
It is a massive intellectual house of cards. The idea that an individual mechanical intelligence can find some Archimedean point of creation to construct a greater intelligence ignores everything we know about the social, situational, and deeply opaque nature of true cognition.
It presupposes that we know what intelligence is mechanically, and then multiplies that error by claiming a machine can manipulate that unknown mechanism better than we can.
Once you dismantle the wiring, you realize the ticking sound isn't a bomb, it's just the sound of an imagination pump working overtime.
Exactly.
Which brings me to a final provocative thought I want to leave you with, building exactly on what we've unpacked today regarding the contextual nature of intelligence.
Okay, what is it?
If true general intelligence is inherently social, situated in time, and deeply tied to navigating human culture, as the failure of the Bob machine suggests, then perhaps an intelligence completely isolated inside a server farm, no matter how powerful its processors, is functionally the most unintelligent entity imaginable.
That is a profound implication. It forces us to question whether intelligence can ever be decoupled from lived experience.
Does true superintelligence actually require a physical body? Does it require mortality, vulnerability, and a society of peers to learn from and interact with in physical space?
And if so, does that render the entire Silicon Valley fantasy of a silicon-based singularity a biological impossibility?
Something for you to mull over as you navigate the endless headlines promising the end of the world. Keep these fallacies in your back pocket. Because everything we discussed today was just the preparation arming you with the